This is problem 2 for the Mathematical Olympiads Discord server 2020 January beginner contest. The Euclidean plane is initially white. On each move, Luciano chooses a system of Cartesian coordinates and paints the region where y is greater than or equal to x squared in red. Is it possible for the Euclidean plane to be painted completely red after a finite number of moves? So the first thing to do is to just try the problem. We start with the parabola, and maybe we could rotate it a bit. Now the rotated parabola covers some amount of the plane, but again there's some gap between the two parabolas, so maybe we could put another parabola into that gap, and we'd get more coverage of the plane. But again, there are two more gaps between those three parabolas now. And then we could fill in that gap with two more parabolas, but you might begin to notice that we will just keep on getting more and more gaps, and perhaps we might never fill in the plane. So here we have a collection of parabolas. Maybe you've convinced yourself that it is indeed impossible to fully cover the plane with a finite number of parabolas. How do we prove it? The key idea here is that a parabola only covers one direction of the plane, which is not formally defined and thus should not appear in your solution, but it does help to give some intuition. The direction that the parabola covers is the axis of symmetry of the parabola. So what we could do is we could consider a line which is not parallel to any of these axes. This is possible to do because there are only a finite number of parabolas as stated in the question. This line is a very interesting line. Since it isn't in the direction of any of the parabolas, you might expect it to only partially be covered by any one parabola. And that is correct. If we consider only one of the parabolas and look at the intersection of the line with the parabola, then indeed, either no intersections, one intersection, or two intersections. And in either of these cases, the line is only covered a finite amount by each parabola. To finish the problem, note that this line is covered a finite amount by a finite number of parabolas, and hence its entire infinite length cannot be fully covered. Hence Luciano, unfortunately, will fail at his task.